Welcome to final countdown, week 8, day 2. Right, let's move in. Right, in the circuit shown, charges of capacitors A and B respectively are. If you look at this, apply Kirchhoff law here. The voltage across this will be 2 volts. If you apply Kirchhoff law here, 2 supply, 2 here, voltage here is going to be 0 volt. That means the charge on A is 0, Q equals CV. Here 2 microcoulomb. Correct answer is answer number 4. Correct answer is answer number 4. Right there. In the smaller loop, we can find the voltage across capacitor B. In the smaller loop, we can find the voltage across capacitor B. And from the bigger loop, the voltage across A will be 0. The voltage across A will be 0. Right. Two boys A and B standing on a horizontal ice surface move apart by pushing on each other. The weight of A is twice that of B. A has moved a distance moved by B is. So law of conservation of linear momentum, 2m times 4, m times x equal 8 meters. Now mass into velocity. Velocity you can write displacement over time. Displacement over time. Time cancel off. X equal 8 meters. X equal 8 meters, answer number 4. X equal 8 meters, answer number 4. Right. Moving on. As shown in the figure, 2 satellites A and B are moving around the planet with velocities VA and VB. So their orbit velocities are square root GM over R. So VA square root R, VB square root 2R. VA over VB is equal to root 2. Correct answer is answer number 3. Correct answer is answer number 3. Right. Moving on. Suppose the times taken for a large aeroplane to accelerate uniformly from 500 to 505 and a car from 50 to 55 and a bicycle from 5 to 10 are the same. Times taken. Consider the following statements. So change in velocity over time, change in velocity over time, change in velocity over time. Accelerations are same, correct. Statement A is correct. All travel the same distance during the above period, wrong. Speeds are different, distances are different. Speeds are different, distances are different. The accelerating force is the same. That's also wrong. Accelerating force is the same. That is also wrong. Why? Masses are different. So only correct statement is answer A. Only correct statement is answer A. Right. A liquid of volume expansivity gamma, forms a liquid thread L0 inside as shown. If the temperature is increased by theta, the length of the thread is, look at the board carefully. Final volume equals initial volume 1 plus gamma theta. Final volume is final area over final length. Initial area over initial length 1 plus gamma theta. What can you say about final area? Initial area 1 plus 2 alpha theta. A1 L naught 1 plus gamma theta. So for A2 you can substitute initial area 1 plus 2 alpha theta, that's beta theta. So A1 cancel off. You can find the new length L2 is equal to L naught 1 plus gamma theta divided by 1 plus 2 alpha theta. 1 plus 2 alpha theta. Correct answer is answer number 4. Fifth one, answer number 4. Right. Read. A thin conducting ring. When they say this, remember always uniform. Subdivide this into small delta Q charges. Subdivide this into small delta Q charges. Subdivide this into small delta Q charges. There you go. Point P is along the axis. Electric potential. Potential is a scalar. So from here to there, always the distance is to take perpendicular from the axis, this location. Wherever you take. Here. So along the axis, wherever, from wherever, here 90. So Pythagoras theorem, r squared plus x squared square root. So potential there is delta q over 4 pi epsilon naught r squared plus x squared square root means to the power half. There are n number of charges. So total charge is q 4 pi epsilon naught r squared plus x squared square root. R squared plus x squared square root. This will give you the answer number 2. This will give you the answer number 2. Right there. Since it is a uniformly distributed ring, we can subdivide it into small charges delta q. We can subdivide this into small charges delta q. Subdivide this into small charges delta q. And find the potential due to each delta q charge at point P. And find the potential due to each delta q charge at point P. Right. Two cylinders contain argon gas and the other contains neon gas are kept at the same temperature. Pressures of the gas must be equal. Mean speeds of the gas atoms of two must be equal. So speed depends on molar mass as well. Okay? The two gases must have mean same translational kinetic energy. That is true. E is equal to 3 over 2 kT. Whatever the gas, the temperature same means kinetic energy same. But root mean squared speed is slightly different. 3 RT over molar mass. Different gases, different molar mass, different speed. So correct answer is going to be answer number 5. Correct answer is going to be answer number 5. Right. Circuit shown uniform magnetic field that is acting into the page. The magnetic field decreases. Electromagnetic induction E is equal to minus delta phi over delta T. Now what? Decreases means we must increase. We must increase means current will go in that direction. Current will go in that direction means there you go, induced EMF is found. Induced EMF is found. Induced EMF. Here B times A over dt. Area is same. Area is same. Area is 0.1 into 0.1, 0.01. dB over dt is 150 Tesla per second. 1.5 volts. So using the right hand rule, I have found the induced EMF 1.5. Now apply Kirchhoff law. Apply Kirchhoff law. Sum of EMF equal sum of potential differences. Here minus to plus positive, plus to minus negative. Resistance is going to be 10 ohm. 10 times I. From this we have 3.5 divided by 10, that is I. I is equal to 0.35 amperes. 0.35 amperes, answer number 2. So flux is reducing, field is reducing. I must oppose the change. I must increase it. Minus means oppose, increase it. Increase it. Increase it means induced current will go that way. Positive, negative terminal here. Right. Right there. Since the field is decreasing inwards. Since the field is decreasing inwards, we must increase the field traveling inwards to oppose the change. We must increase the field traveling inwards to oppose the change. To oppose the change. Therefore, we can find the induced EMF and the net current. We can find the induced EMF and the net current. Okay. A laser beam 1 millimeter diameter has to be converted to 10 millimeter diameter. What value of focal length f2 for the second lens and distance d? It should be placed from the first lens. Focal length here. So using your basic knowledge, you should know this. So opposite over adjacent, that is equal to opposite over adjacent. F2 is equal to 15 centimeters. F2 is equal to 15 centimeters. Distance between them is 15 plus 1, 16.5. So 15 centimeters, 16.5. Correct answer, answer number 5. Correct answer, answer number 5. Right. The near point of a defective eye is 50. Normally near point should be 25. He is far away. That means long sighted. The lens that should be worn to correct the near point, 25 is. So you have a vision issue. So long sightedness corrected by convex lens. Object is kept at 25. Image is formed where the eye can see. Where can the eye see? I can see at 50 centimeters. So 1 over V minus 1 over U equals 1 over F. Object at 25. Image is formed at 50, focal length F. Common denominator 50, 1 minus 2 F. F is equal to minus 50 centimeters. So convex lens 50 centimeters, answer number 1. Convex lens 50 centimeter, answer number 1. Right. Next one. An earthquake which occurs at a certain location generates S waves and a longitudinal P wave. Both waves travel through the earth and P waves arrive 3 minutes before S waves. Primary waves are much more faster. So distance divided by speed. Primary waves are faster. Time taken by primary is less. speed of secondary is smaller, time is more. So Ts minus Tp is d 1 over Vs. Sorry. So wait. Time taken is shorter, time taken is longer, right? Okay. So they are telling you secondary waves 4, primary waves faster, right? So time gap is how much? 3 minutes, 180 seconds. Distance we don't know. Kilometers per second. 1 over 4, 1 over 8 primary. First multiply 8 or 2 minus 1. D is 180 multiplied by 8. So per second cancel. 1440 kilometers. Answer is answer number 4. 1440 kilometers. Answer is answer number 4. The diagram shows a balance meter bridge. P indicates a pair of identical wires. Identical wires means equal resistors, right? When one resistor is removed, the new balance length is approximately. So effective resistance here R over 2. This is like a meter bridge. So which principle? Wheatstone bridge principle. So here the resistor here is, let's say, R dash. So R over 2 divided by R dash, 50 divided by 50. Therefore R dash is also R divided by 2, right? Now if one resistor is removed, what is your new balance length? New balance length. R divided by R dash, R divided by R dash, R divided by R dash. That's going to be L divided by 100 minus L. Simplify this carefully. R dash is R over 2. R over 2. L divided by 100 minus L. 200 minus 2L L. 200 equals 3L. L equals 66.67. So L is equal to 66.67 centimeters. So 66.67 means approximately answer 4. So this divided by that is that over that. Meter bridge means here 50. Now next case I am removing this R. Only one R is there. R over R dash is L over 100 minus L. So this is your initial situation. This is your final situation. From there you can find new balance length. New balance length. Question number 30. Question number 30. Right. Two small plastic spheres A and B, one hollow, one solid, made from same material, have same radius released from a tall building. Both spheres reach their terminal velocity before hitting the ground. Important point is one is hollow, one is solid, made from the same material and having same radius. When the spheres reach the ground, one is hollow, one is solid. Right. So, which will have the bigger speed? Obvious, no? mg balances 6 pi eta rv. Greater the weight, greater the velocity. Who will have? Both are having same material. One is hollow, one is solid. Same radius. Solid will have the greater weight. If solid has the greater weight, here, solid has the greater weight, they are asking what will happen. Viscous force on A will be lesser than that of B. Viscous force on B is more. Weight is more. No? So correct answer is answer number 2. m increases, 6 pi eta rv will also increase. Mass of B is larger than mass of A. Viscous force of B is greater than viscous force of A. Very simple. Okay. So direct relationships can be found. Next one. The moment of inertia of a ring of mass m about point A is given. Right. About point A is given. So about point A means we can subdivide this into small masses. Subdivide this into small masses like this. Subdivide this into small masses. Subdivide this into small masses, right? Figure 1, moment of inertia 2mr squared. Please look at the board carefully. If I consider this, if I consider this one, here to here the distance is x, here to here the distance is x. Distance x, distance x. Now let me take here to here distance y, here to here distance y. You can see the distances don't change. Here to here, here to here. Distances don't change. Distances don't change means moment of inertia should also not change. Right there. If we subdivide it into small delta m masses, if we subdivide this into small delta m masses, we can show that the distances do not change. The distances do not change. Therefore, the moment of inertia will also not change. Therefore, the moment of inertia will also not change. Right? Next one. System of coplanar forces are given. Resultant force. Now, equal vectors will cancel off. This vector will cancel off. This is bigger. Resultant is up to there. This is bigger. Resultant is up to there. This is bigger. Resultant is up to there, right? Only these three are the resultant. Now what? What is your resultant vector? Start from one vector. Where it ends, start the other vector. Then these also taken. Where that ends, start the other vector. Now join the initial terminal. Now join the initial terminal. That's your resultant. So resultant will be in what direction? Resultant will be, if you look at this, somewhere closer to C, no? OC direction maybe, no? OC direction. OC direction, yes. Here, parallel, parallel. So parallel to that. Next one. A wooden block is sliding down inclined plane, constant speed. Work done by external force, increase in kinetic energy plus work done by resistive forces. External force is mg sin theta multiplied by x. Increase in kinetic energy is 0. Work done by resistive force into x. Energy dissipated due to friction. X sine theta is h. So mgh. This is work done by friction. Work done by friction. mgh is your answer. Correct answer is answer number 4. 16th answer number 4. The very basic work. Two identical conducting spheres carry equal amount of charge. Two identical conducting spheres carry equal amount of charge, Q and Q. The spheres are separated by a distance which is much larger than the diameter. Electrostatic force of attraction between them, so repulsive force, is F. Now, a third identical uncharged conductor is first made to touch A. Look at the board. First I am touching A. When it touches A, what happens? Charges will equally divide. Charges will equally divide. Q over 2. And secondly, it will touch B. 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 Total charge 3Q over 2, 1.5. 3Q over 4. Now what is left? A will have Q over 2. B will have 3Q over 4. Total is 1.5. 3Q over 2 equal, divide by 2. And this will have 3Q over 4, right? Okay, now they are asking the force. So now they are asking the force. So basic logic. What's the new force? F dash. F is proportional to product of the charges, Q square. F dash is proportional to product of the charges, Q over 2, 3Q squared over 8. So the force is going to be what? 3F over 8. Answer is answer number 4. Answer is answer number 4. Simple but important. So here force, once it touches, total charge will equally divide. So total charge is 3Q over 2, 3Q over 4, 3Q over 4. If I touch here, total charge here is Q, equally divide. Q over 2, Q over 2. Right. Force proportional to product of charges. New force is product of the charges. So Q squared is F, means new F is 3F over 8. Right. Right. Carefully look. Carefully look. A standard length of a filament was shortened due to a certain defect. You shorten the length means you shorten the resistance. It will glow brighter and consume more power than standard 60 watt. So don't forget, power is equal to V squared over R. Power equals 60 watt. 230 squared over R. R equals 230 squared divided by 60. Now if I shorten it, resistance will reduce. Length reduces, resistance reduces. Resistance reduces, current will increase. Don't forget. Current in the circuit will increase. Right. A. It will grow brighter and consume more power than 60 watt bulb. Statement A. Glow brighter. Now brightness depends on potential difference. Now 230 volt supply. Current also has increased. consume more power, I squared R or VI. I increases, VI increases. Statement A is correct. Wavelength corresponding to the maximum intensity of light will be lower than that of a standard 60 watt bulb. Maximum intensity will be lower. Now this is connected to radiation. So all of you all know wavelength becomes lower. Why? Intensity of light is more. More intensity means greater area. Greater area means wavelength will reduce. Correct. Surface temperature of the glass envelope of the bulb will be higher. Yes. When the intensity increases, Q dot increases, temperature will increase. C correct. A, B, C all are correct. Don't forget, this is connected to radiation and electricity. Yeah? Connected to radiation and electricity. Yeah. So when intensity increases, the area of the curve will increase. Area of the curve increases. Area increases means it gets closer. The wavelength reduces. Wavelength reduces. That means temperature will increase according to Stefan's law. A long uniform resistance is cut to n numbers of equal length. These pieces are bundled together to make a composite wire of length equal to a single length. So resistors are in parallel. So resistor proportional to L. If I cut to n number of parts, resistance also R over N. There. If I divide it by N, resistance also R over N. So 1 over R equivalent is 1 over R over N times N. So R equivalent is equal to, turn upside down, R over N squared. R over N squared. The composite wire is R over N squared. Answer number 5. R over N squared, answer number 5. Right. Resistance across XY network. Now, X terminal is here. Don't complicate this. These are very simple things. If you look at it carefully, non-resistant wires. Non-resistant wires means every single location the potential is same as Y. Every single location the potential is same as Y. That means it is as if all of them were joined together at Y. All of them were joined together at Y. You think and tell me below. How many resistors? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All 10 are what? Connected to each other. So if I draw it here, all 10 resistors are connected parallel to each other. Here you go Y. All resistors are R. Right. Then look at these terminals. Their potentials will be same. Their potentials will be same. Okay. Their potentials will be guaranteed same. Right. Now what can you say here? Think carefully and answer. Here R divided by R divided by R same. Can you see this carefully? Look at it carefully. Every single location here potentials are same. Same potential means there won't be current passing through. All these resistors you can remove. Here, same potential. This resistor can be removed. Then 1, 2, 3, 4, 5. 5 resistors connected to X. Five resistors connected to X. So potentials are same, current won't go. This is removed. So for X terminal 1, 2, 3, 4, 5. 5 are connected. Now what is your effective resistance? Here R. No? Here R. Here also R. Parallel resistors R over 5, R over 10 between X and Y. Here 3R over 10. 3R over 10 means answer number 5. 3R over 10 means answer number 5. These are very simple questions. Huh? Non-resistant wire potentials are same as Y. All are connected to here, this point. So potentials are same. No current will go across this. These are removed. All the other 5 resistors connected to X. So here parallel, simplify, get the answer. Right now. Next one. Have a look. A student wants to determine the specific heat capacity of a liquid using method of cooling. These practicals are done. Guaranteed you can score marks. For this, he plans to obtain cooling curves for water and liquid separately. All necessary equipment for the experiment have been provided. In this experiment, it is important to use equal volumes of water and liquid. What is the reason? Equal volumes of water and liquid. So the cooling conditions are the same. So that the cooling conditions are the same. Right? So important idea there is the cooling conditions should be the same. The basic cooling conditions should always be the same. And the area in contact with liquid and water must be equal. Right. Figure shows different levels. Of these 3 levels, up to which level the student should fill the liquid? Up to which level? L1. Give reasons. The area which is not in contact. Area which is not in contact with the liquid. Or water must be minimum. What experimental steps should the student follow in order to make sure that the thermometer immersed in water or liquid reaches the temperature of the calorimeter surface? Continuously stir. continuously stir. So if you keep on continuously stirring, the temperature of the outer surface and inner both will be same. Two cooling curves are obtained. There are two cooling curves here. You can see here. Two cooling curves. Other data in the experiment is heat capacity is given, mass of water, specific heat capacity of water, mass of liquid. What's the average rate of heat loss from for water from 55 to 45? Right. 55 to 45. 55 to 45. Here you go. 45. Properly indicate 55. Here 55. 55 to 45. Simplify this carefully. So time taken there is 4 minutes. Time taken there is 4 minutes. Time taken there is 4 minutes. There you go. So the average rate of heat loss. Heat loss by water 55 to 45. 4 minutes. Convert to seconds. Heat capacity C vessel 4 minutes into 60. Mass of water 0.2, 4000, 10 divided by 240, 112, 10 divided by 240. Simplify this. You get your answer in terms of what? You get your answer in terms of what? To simplify it, $38. Calculate the specific heat capacity of the liquid. Now remember, here for the liquid 2 to 4, 2 minutes. So if I write the equation, the rate of heat loss is the same. Mass of liquid, specific heat capacity of liquid, 55 minus 45 divided by 2 minutes into seconds plus. Here C12, 112, 55 minus 45 divided by 2 times 60. 38. Mass of the liquid 0.172. 0.172. 10 divided by 112. 10 over 120. Simplify this, you can find the specific heat capacity of the liquid. Specific heat capacity of the liquid. So if you do the calculation, 38 2000 joules per kilogram per Kelvin. 2000 joules per kilogram per Kelvin. Right. Why is it not suitable to use a glass container in place of a calorimeter? Now, glass container, we have a small issue. There will be a temperature gradient. There will be a temperature gradient. Therefore, inner surface temperature and outer surface temperature, inner surface temperature and outer surface temperature will not be the same. Okay, no? Inner surface temperature and outer surface temperature will not be the same. Right. Look at this carefully. Essay question. Figure shows ripples moving in the x direction. Here is your x direction. Ripples are going in the x direction. Right. Okay. Now what? When ripples are traveling in the x direction, liquid at the surface performs simple harmonic motion. So when the ripples are going at the surface, they undergo simple harmonic motion. A stationary sound source detector is placed above the liquid surface to study the vertical motion of a given location of the liquid surface due to the propagation of the wave. So the wave is going this way. Waves are knocking here. So this is going up and down. So depending on the up and down, there is a sound wave coming, knocking and reflecting. Right. The sound source sends signals vertically downwards and the reflected signal is detected by the detector. So receiver and detector both are same. The detector is also capable of determining the frequency of the beats produced by the waves emitted and received. Emitted by the source and received from reflection. So the difference only is the beat. The frequency of the sound wave is 680 kilohertz, speed of sound in air 340. Right. Okay. At what position shown in figure A or B, speed is minimum. Speed is minimum at B. What is the value of the speed? Minimum speed is 0 at the highest location. Minimum speed is 0 at the highest location. So these are basic questions they will ask. In simple harmonic motion, the lowest speed is there at the highest location. Greatest oscillation. Right. Okay. What is the frequency of the reflected sound wave at this instant when the speed of the liquid surface is minimum? Right. Observe. Here you have a source. This is your observer at rest. Sound waves are coming, knocking on this. Here F dash, here F. These are at rest. That's the wave. Then reflection takes place. That's your observer. That's also at rest. Here F double dash. Remember, this is your wave. There is no relative motion. Actual frequency and apparent frequency both are what? Same. So here also F means here also F. So what is the frequency reflected at the instant when the speed is minimum? Frequency reflected is also same as received, 680 kilohertz. 680 kilohertz. Right. Next one. If the speed of sound in air and frequency of the sound waves emitted by the source are u and f naught respectively, write an expression for the frequency f dash as observed by the liquid surface. When liquid surface is moving away from the sound source with a velocity v. The wave is going away, observer is going away with a velocity v. Source is at rest. Sound waves are traveling with a velocity u, frequency f naught. They are asking you frequency f dash observed at the liquid surface. Velocity of sound with respect to observer. Velocity of sound with respect to observer. Velocity of sound with respect to source into actual frequency. U minus V divided by U into F naught. U minus V divided by U into F naught. Right. So Doppler effect. Stationary source, observer moving away. Stationary source, observer moving away. Right. For the situation described, obtain expression for f double dash measured by the detector in terms of V, F naught and U. Right. Now what happens? The observer will become the reflector. And this will become the observer. Temporary source. Observer is at rest. F double dash. Velocity of sound with respect to observer. Velocity of sound with respect to source. Into frequency f dash. F double dash is u over u plus v. What is f dash? U minus v divided by u f naught. F double dash is u minus v divided by u plus v f naught. U minus v divided by u plus v f naught. Right. Using your expression in Roman 2 and Roman 2b, so that when v is very small compared to u, beat frequency measured. Now what do you mean by beat frequency measured? Emitted frequency and received frequency. Emitted frequency is f naught. Received frequency is f double dash. Substitute. U minus v divided by u plus v into f naught. Simplify the relationship. Beat frequency. F naught, take it out. U plus v minus u plus v. U plus v. U cancel off. Beat frequency is 2v f naught u plus v. Now v is much more smaller than u. V is much more smaller than u. U plus v is approximately u. So your beat frequency is 2v f naught divided by u. 2v f naught divided by u. That is your beat frequency. Right? These are not difficult. At what position A or B of the liquid surface can the maximum frequency be detected? Beat frequency. So beat frequency is 2v f naught over u. Now what is u? U is velocity of sound, v is the speed. So maximum can be obtained only at what? Where the maximum velocity is. Maximum velocity is what? At A. So maximum beat is also at A. Therefore, maximum beat is obtained where there is maximum speed. Where there is maximum speed, which is at A. Which is at A. If this frequency is 600, find the magnitude of the velocity of the liquid surface. So beat frequency 600 to V, f naught is 680 kilohertz. U is 320. V equals 600 multiplied by 320. 2 multiplied by 680 into 10 to the power 3. Simplify this. Simplify this. Point 14 meters per second. Sorry, this is 340. I think they are given, yes, 340. So this is 340. Then write 340. So velocity can be found. Velocity 0.15 meters per second. 0.15 meters per second. 0.15 meters per second. Okay, right. Okay, now. Sketch the value of the beat frequency measured by the data as a function of time for the complete period of oscillation. Beat will never become negative. 0, T over 4, T over 2, 3T over 4 periodic time. Right. So if you sketch the variation, where is it starting from? A to B, B to C. Let's say goes up, comes down. Right. Maximum beat is there. So starting from B, B is 0. Here maximum. Again comes to 0. Again here maximum. Again comes to 0. So there you go, that's how the beat frequency changes. Right. Next, if the time interval between two successive zero values of the beat frequency, so that is half a periodic time, 0.05, t is 0.1 second, frequency is 1 no periodic time. What's your answer? 10 hertz. 10 hertz. For small wavelengths, speed v of the ripples on the liquid are given. T lambda rho are surface tension, wavelength, ripples and density of the liquid. If lambda is 12 millimeter, rho is 13,600, obtain value for T. So V is equal to 2 pi T lambda rho square root, same as F lambda. So here 2 pi surface tension, lambda 12 millimeter convert to meter, rho is 13,600 square root, frequency is 10 hertz, 12 millimeter convert to meter, square both sides, 60, 12, 10 to the power minus 3, 13,600, 120, 10 to the power minus 3 squared, 10 to the power minus 3 squared. From this you can make T the subject. Ohms per Newton per meter. From this you get 120 10 to the power minus 3 squared, 12 into 13,600, 10 to the power minus 3, 0.39 Newton per meter. 0.39 Newton per meter. Okay. 0.39 Newton per meter. Right. Okay. So this concludes the discussion for week 8, day 2. Catch you tomorrow with week 8, day 3.